Hello, welcome. I'm Milan Niska, a Microsoft technical trainer. This course covers 6 sessions where learners will build a foundational understanding of core data concepts and how data is stored, processed, analyzed, and visualized in Microsoft Azure. In this session, we'll cover an introduction to data analytics in Microsoft Azure. Let's get started with session 4. Welcome to explore fundamentals of data analytics. Up to this point in the course, we focus on how data is stored and managed to support day-to-day business operations. In this module, we shift our focus to analytics workloads, how organizations turn raw data into insights. We'll look at how data is ingested, processed, stored, and analyzed at a scale. And we will introduce the Azure services used to support reporting, analysis, and decision-making. We will focus on analytics workloads in Azure and how organizations turn data into insights. We'll start by exploring large-scale data analytics, looking at how data is ingested, processed, and stored for analysis at a scale. Next, we will examine streaming and real-time analytics, where data is processed as it arrives to support near real-time decisions. Finally, we'll look at data visualization and how tools like Power BI help transform analytical results into reports and dashboards that support business decision-making. The goal throughout this module is to recognize, understanding which type of analytics workload you are dealing with and which Azure services are designed to support it. After completing this module, you'll be able to recognize the key features of large-scale analytical solutions, how data is ingested, processed, stored, and analyzed at a scale. You'll also be able to describe the common characteristics of real-time analytics solutions, where data is processed as it arrives to support near real-time decisions. Finally, you'll understand important considerations for your data visualization, including how analytical results are presented in reports and dashboards to support business decision-making. Large-scale data analytics is about understanding what's happening across the business by analyzing very large volumes of data. Instead of focusing on individual transactions, these solutions look for trends, patterns, and aggregates across time, customers, products, or regions. Data often comes from many sources and in many formats. It is ingested in batches or streams, transformed for analysis, and stored in systems designed for heavy read-intensive queries. The goal is insights, supporting reporting, analysis, and decision-making without impacting the performance of operational systems. In Azure, large-scale analytics commonly uses data lakes, lakehouses, or data warehouses combined with processing engines that can scale out as data volumes grow. The key idea is recognizing when a workload is analytical in nature and which types of Azure services are designed to support analysis at a scale. Large-scale data analytics solutions combine two approaches. First, they build on traditional data warehousing, which is commonly used for business intelligence. In this model, data is copied from transactional systems into a relational database with a schema optimized for querying and reporting. Multi-dimensional models are often created to support analysis across measures like time, product, or region. Second, these solutions incorporate big data analytics techniques. In these scenarios, very large volumes of data, often in multiple formats, are batch loaded or captured as real-time streams. This data is stored in a data lake and processed at a scale using distributed engines such as Apache Spark. While architectures and technologies can vary, most large-scale analytics solutions include 4 common components. First, data ingestion and processing. Data is collected from transactional systems, file, real-time streams, and other sources, and loaded into a data lake or data warehouse. This process typically uses ETL, where data is cleaned, filtered, reshaped for analysis. Processing is often handled by distributed systems that can work in parallel across multiple nodes and supports both batch and real-time processing. Second, the analytical data store. This is where prepared data is stored for analysis. Common options include relational data warehouses, file-based data lakes, and hybrid architectures that combine both, often referred to as lakehouses. Third, the analytical data model. To make analysis easier and faster, data is often organized into models that pre-aggregate values. These are commonly described as cubes, where numeric data is summarized across one or more dimensions, enabling drill down and roll up analysis. Finally, data visualization. Analysts and increasingly business users consume data through reports, dashboards, and interactive visuals. These visualizations highlight trends, comparisons, and key performance indicators, and can appear in dashboards, documents, presentations, or self-service analytic tools. Large-scale data analytics solutions rely on data processing engine that can ingest, transform, and query data at scale. Because these workloads often involve very large volumes of data, most analytics processing engines use the distributed architecture. That means processing tasks run in parallel across multiple nodes in a cluster, rather than in a single machine. There are many technologies that can support distributed data processing, but most modern analytic solutions are built around two common approaches. The first is relational database engines. Relational databases have been a core part of data solutions for many years, including analytics scenarios. They process structured query language, or SQL, which allows users and tools to load data into tables, filter and aggregate it, and perform analytical operations using familiar relational concepts. This approach works especially well when the data is structured and fits a tabular model. Second approach is Apache Spark. Apache Spark is an open source platform designed specifically for large-scale distributed data processing. It scales by distributing work across multiple worker nodes, enabling complex transformations and queries over large datasets. Spark has become one of the most widely used technologies for analytics at scale and sits at the core of many modern analytics services. Spark supports multiple programming languages, including Python, Scala, Java, and SQL, which make it a flexible option for working with both structured and unstructured data. The idea is recognizing when analytic solutions rely on relational engines, Spark-based processing, or a combination of both to process data efficiently at a scale. As discussed earlier, there are two common ways to implement an analytical data store. The first is data warehouse. A data warehouse is a relational database that is optimized for analytics rather than transactional workloads. Data from operational systems is typically copied into a warehouse and stored in a denormalized schema that's designed for fast querying. In this model, numerical values are stored in central fact tables, which are related to dimension tables, such as customer, product, location, or time. This design makes it easier to aggregate data, for example, calculating monthly sales by product and store. This structure is known as a start schema, and it's sometimes extended into a snowflake schema when dimension tables are further broken down into hierarchies, such as products and product categories. Data warehouses are a strong choice when your data is highly structured and you want to analyze it using SQL. The second approach is a data lake. A data lake is a file-based storage system, usually built on a distributed file system for high-performance access. Data is stored as files, often in multiple formats, and processed using technologies like Apache Spark. Data lakes typically use a schema-on-read approach. Instead of enforcing schema when data is written, the structure is applied at the query time. This makes data lakes well suited for analyzing structured, semi-structured, and even unstructured data without strict constraints upfront. A more recent approach in this is the data lake house. In a lakehouse architecture, raw data is stored in a data lake, but a relational layer sits on top of the files and exposes them as tables. That can be queried using SQL technologies like Delta Lake. Enable this by adding transactional consistency, schema enforcement, and support from both batch and streaming data. The key idea is to recognize when a workload fits best with a data warehouse or a data lake or a lakehouse, and understanding the trade-offs of each architecture. Azure Databricks is an Azure implementation of a Databricks platform, which is built on Apache Spark. It provides a comprehensive analytics environment that supports large-scale data processing, data analytics, and data science workloads. Azure Databricks includes native SQL capabilities optimized for Spark runtimes and an interactive workspace where teams can explore data and collaborate using notebooks. Because Databricks is widely used across multiple cloud platforms, Azure Databricks is a strong choice when organizations already have experience with the Databricks platform. They need support in multi-cloud architectures or want to have a solution that is portable across environments. Again, the key idea is recognizing Azure Databricks as a Spark-based analytics platform that supports scalable data processing in advanced analytics scenarios in Azure. Scalable analytics with platform as a service services can be complex, fragmented, and expensive. With Microsoft Fabric, you don't have to spend all of your time combining various services and implementing interfaces through which business users can access them. Instead, you can use a single product that is easy to understand, set up, create, and manage. Fabric is a unified software as a service offering with all your data stored in a single open format like OneLake. OneLake is the Fabric's lake-centric architecture that provides a single integrated environment for data professionals and the business to collaborate on data projects. Think of it like OneDrive for data. OneLake combines storage locations across different regions and clouds into a single logical lake without moving or duplicating data. Data can be stored in any format in OneLake and can be structured or unstructured. For tabular data, the analytical engines in Fabric will write data in Delta format when writing to OneLake. All engines will know how to read this format and treat Delta files as tables no matter which engine writes it. Now it is time for a demo. Let's explore data analytics in Microsoft Fabric. All right, let's open Edge first, then go for Fabric. We'll use real-world datasets to practice data ingestion and analysis in Microsoft Fabric. Let's create a workspace. New, Let's give it a name. Can be any name. Hit OK. It will take a second. Close this out. See, it is empty. This is normal. Let's create a lake house. So I go to the left-hand side, create, and we'll select lake house. We need to give it a name. The location will be the workplace. Create, and it created our lake house. We can see tables and files. This is still empty. This is table folders. This files that is also empty. Contains data files in OneLake storage. Currently, there's nothing here, so we'll get data with a copy that activity in a pipeline to extract the data from a source and copy it to a file in the lakehouse. So let's do that in the home page for your lakehouse in the Get Data menu. And select New Pipeline. We need to give it a name. Ingest data. Create. Will take a second. We will select sample data because we're not really connecting to anything. This is a very good one. New York City taxi green. I'll select that one. It is generating the preview. Wait for it. Perfect. You can see the trips there. Let's go next. And we will name the table. Let's call it taxi. It is a new table, and the root folder is the table. Next. We're not enabling partitions now. They are very useful normally, but for the demo, we'll keep it simple. And we'll start the data transfer immediately. So after save and run, we can run a query. So data is being copied over. Let's query the Lighthouse. Select from the Lighthouse the SQL Analytics endpoint, new query. There it is, new query. And we'll use this query. And you can see I'm already getting results out of it. Averages, Monday, Wednesday. And that's it. Let's stop for a quick knowledge check to reinforce the analytics concepts that we just covered. Let's go with the first question. Which term is used to describe an analytics solution that combines data lake and relational data warehouse functionality? And the correct answer is data lakehouse. A lakehouse combines the scalable file-based storage of data lake with the structured querying and analytics capabilities of a relational data warehouse. Let's go to the second question. What must you define to implement a pipeline that reads data from Azure Blob Storage? The correct answer is a linked service for your Azure Blob Storage account. A linked service defines the connection details that allow a pipeline to securely access external data sources. Let's go to the third question. Which open source distributed processing engine does Microsoft Fabric include? The correct answer is Apache Spark. Microsoft Fabric uses Apache Spark to process large volumes of data in a distributed and scalable way. If these answers make sense to you, you're on track with the core analytics concepts needed. This wraps up session 4. You should now be able to recognize the key features of large-scale analytical solutions, how data is ingested, processed, stored, and analyzed at a scale. We also discussed the common characteristics of real-time analytics solutions where data is processed as it arrives to support near real-time decisions. Finally, we looked at important considerations for data visualization, including how analytical results are presented in reports and dashboards to support business decision-making. This concludes our session. We hope you join us as we journey through the course. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.